Hi everyone, today I'm working on a hobby project of mine called Mathris, which combines, maths and Tetris, kind of. So the gameplay is actually relatively straightforward. You've got your AI opponent on the right, you've got your own board on the left. What you need to do is basically answer some of these questions related to basic maths operations. And the goal is to finish the board, to complete it before your opponent. So the gameplay is already there, so I'm just going to try and add quality of life improvements. I'd like to have some kind of a scoreboard thing so that I actually don't know what I'm going to do with the score. So maybe just have the score somewhere here for now, and then it captures how many blocks have been destroyed or something like that. And then currently what the AI does, it cheats. It looks at the answer and then uses it as the answer with particular value set for accuracy. But if we apply some kind of sort of negative effects, then that doesn't hinder the AI. So the AI kind of isn't affected by the effects that we apply. So that needs to be fixed. I think these are going to be the two major things that I'll be adding today. Right, let's add a to-do list somewhere here. So 1, we need a score thing. 2, we need AI is not hindered by the power-ups, which is a bad thing because we've got this nightmare level AI, which is somewhere here, which has a 95% accuracy. So it's actually pretty brutal. So we need these power-ups to help the player be able to actually beat the AI. Right, score. Where do we go for that? Probably somewhere in the player component. Yeah, let's just keep an integer property called score. Then we need to be able to read the score from this class, so score property. I'm not sure how we're going to be updating it though. Probably through this thing. It's currently add streak. That's called when the player destroys a block. So if we use that add streak as a way to notify the player component that something has happened, as in the score needs updating, then we can do something like score set score get plus I don't know. So is it going to be some kind of multiplier? Like if you get a few in a row, the score needs to be higher, presumably. We'll leave that for now. This reset thing is what I wanted to update. So score set to 0. This is called when the new level starts. So it resets the player, both players, to their kind of default values, which is what we want. So add streak is going to capture the time when the last kind of hit occurred. Something like time scored. This is in seconds. Can we get a timer of some kind? Game timer, that should do it. Local timer. Is that captures the current time, and then we can check if something has elapsed or not. Yeah, I suppose we could do it the other way. So capture the current time, and then we give a particular interval. If the next call is within this interval, then what? Then we update the score. Okay, let's try that. So this is then a local timer, and then score timer. That should work. And then somewhere here, we need to capture timer, capture the time, and then this needs to be after though, right? And then if score timer elapsed some kind of duration, which could be inside config, bonus score duration or interval. Basically what we're saying is if the second scoring event occurred within 0.5 of a second after the previous one, actually no, it's elapsed, so the logic is backwards. If this thing elapsed, which is config bonus score interval, then we do not award points. Else, so we need to flip that, we give bonus points. And then we capture. That should work. Right, we need some kind of base points. Base score is 100, I guess. We don't really have anything to measure against, so we'll just go with that for now. And then if it's within the interval, then this is where we add a multiplier, or score multiplier, which is something like 2, I guess, as a start. Is bonus, something like this. Base score, and then multiplier is is bonus, then this, else the base 1.0. And there's a base score multiplied by the multiplier. That's an int. Almost everything is an int in this game, so let's keep this to an int then. Just keep it simple. Now we probably want to have some kind of a user interface indication. So we need a text object. Where is our UI? There we go. Yep. And then we probably want to have, this is player UI, this is separator, and then let's add the score somewhere here actually. Probably need to separate this into multiple methods, but we haven't added stuff yet to justify separating at this point. What is a score in the UI? It's a text object, right? So score1 text. It can bind to a string expression, which is kind of what we want. Oh yeah, I suppose we could bind it later as well. It's player1 dot score property as string it's an int, so just that really. Don't think we even need this. And then score2, player2, and then we add both UI nodes. Score1, add score2. Score2, where do we add it? So if this thing is 840, so it's 840 and get up height minus 50, something like this. And this is maybe something like 720. The height needs to be the same. I think that's, yeah. The width, or rather. Now here's the problem, because this thing goes from left to right, so player 2 score is actually fine. It kind of, does it interfere with text? Do we need to, probably want to change the color so it differentiates from the input. This one is actually spot on in terms of layout positioning. Maybe just drop it further down on the y-axis. But this is going to be a problem, and you'll see why. Because if it goes up, 39, 24, 34, 40, 31, 20, 33. It's not going to be aligned with whatever line we're going to try and align it to, because it goes from left to right. So what we want is check the layout bounds of this text object and then use its width, and then go from this line, whatever that line is. Set it to 720. So it's got to be something like, I don't know, 750. Okay, let's find the line first. So let's go 750 and then drop this something like this. That should do it. And then change the color to gold. Let's go with gold. Yeah, I'm pretty happy with positioning. So this line seems to be at around 750, which is fine. Maybe 740, just a little bit, 745. Use that as a basis for the right side, then subtract the width of the text object to figure out where to position the left side of the object. That trick should do it. So score 1. Actually, by default, we could just position it there. That's kind of when the value is 0. When the value is not 0, we need to do something with it. Layout bounds. Nope, we need some kind of a property that we can listen for changes in. Layout bounds property. Yeah, this is the one. This is new bounds. That means something has changed. It doesn't grow on the y-axis, so the only way it changes if it grows in the x-axis, which is what we want. So score 1 set translate x to 745, which is that side, minus new bounds width. Yes, I think that works. Does it? Not quite. It kind of moves it further. Something like 755. Why does it move this thing further? Oh, because 745 is the left-hand side of the original of the 0. So it's the value here should be 745 plus the width of the 0, which is not something I know. Once we've constructed this object, does it know its bounds? If it does, then that would simplify a lot of things. And then it's the same value. Good. Now it doesn't shift. Cool. Now we need to figure out what the score actually does, probably in the future at some point. For now, I need to fix the AI's cheating mechanism. Right, so the score is done, at least as far as I'm concerned. AI is not hindered by the power-ups. Yeah, that's right. So we need to figure out AI stuff is here somewhere. That's the one. So the guess interval is well, it's fixed, as in given some kind of a difficulty, given the level of difficulty for the AI, that specific AI is always going to guess at a given interval. So that doesn't change between guesses. What we can affect is the accuracy. So the nightmare level AI, for example, just here, that's 1 second guess interval. So it will still keep guessing every second, but its accuracy is going to go down depending on what kind of effects are being applied. So I think that stuff shouldn't be here. It needs to have an extra thing in here, I think. What if it's accuracy drop per digit? How about that? So depending on how many digits there are in the answer, if it's a big number, it's going to have more digits in it. So I think it makes sense that the bigger the number, the lower the accuracy is going to be for that. It's also in the range that is in kind of fractional range. So 1, it should never be 1, otherwise it's a drop per digit. So every digit will make it 100% worse for accuracy reasons. So, but at least this gives us a range to work with. Right, so config, yeah. Now let us consider the maximum value in this game in terms of answers. It's probably, so this is where we set the kind of what the operations are going to be depending on the level. It's not just pluses all the time. It's just the first level is the only operation is maths add. But other levels are going to have something like subtract, multiply, divide, and then so on. Power, that could be interesting. So this is 10 and this is cubed. 10 squared is 100 and then cubed is 1,000, right? That's how it works. So I think that's the maximum value that the answer can be, 1,000. So 4 digits. Multiplication 25 by 25, that's 625. It's less than 1,000. And then there's this power up / negative effect, which is called big numbers, which will, yeah, this needs to be figured out and fixed. What does it actually do? This goes up to 500, 500, and then it basically changes the block, or one of them, to the plus operation. Wait, how do we do it normally through the factory? Question is a plus this. Yeah, we should do that, because now we have an actual operation type. And the operation is add. Okay, so now that's the same as if it was created through the factory, which is good. Because if the code is identical, then we can refactor it easily in the future. This also goes to 1,000, right? So this is the maximum value, this is the maximum value, the sum of which is 1,000. So there are 4 digits is basically what we've got. For now, max is 4. Max answer is 4 digits. Which means whatever the percentage we put here, that's the percentage drop multiplied by 4 if we're answering, from the AI's perspective, if we're answering a complex question. Which means even a single digit answer is going to have a drop, which is fine because we can adjust the base accuracy. Base accuracy. Comments and strings, no factor. Accuracy drop per digit. And then presumably there are various other accuracy drops based on effects. I'm just trying to make this more general so that in the future, if we end up with new power-ups, it doesn't cause any issues. Right, let's start from nightmare. So its base accuracy is actually 1.0, or that's what it's going to be. 100% accurate. And then the drop is 0.5. If we multiply 0.5 by 4, well, it's 0.05. That gives us 20, right? So it's 0.2, which is 20%, which makes it 80% accurate. For kind of big numbers, big meaning 4 digits. Most of the time it's going to be 1, 2, or 3 digits. So it goes up to 15%. If it's a single digit, which is a guaranteed value, that gives us 0.95, what it was before. Yeah, I think that's a good value. Hard is, I don't know. So it has a 2-second interval. That's going to guess. Hard should be hard. So let's make it 85% accurate, and it has a drop of 0.005 as well. So there is a clear difference between hard and nightmare. Like nightmare is supposed to be really hard, right? So I think that's fine. Medium is 50%, that's low for medium, I think. It needs to have 65% accuracy as a base accuracy. And then it's going to struggle as it reaches high numbers. Medium 3 seconds, maybe 2 seconds, because medium isn't supposed to be that easy. So 3 digits, which is kind of the effective big number, because 1,000 is rare, right? So it's going to be 3 digits-ish. That's 30%. That brings it down to 35% accurate. Yeah, maybe it should be something like this. Also, we should be able to actually position these. Something like that. So we can clearly see the difference. There we go. That's a bit better. And then a 3-second delay, 25% accuracy. No, that's never going to answer anything. That should probably be 0.5, so 50%. And then one massive drop per digit. Because even a single digit is going to cause this thing to kick in, right? So maybe even higher, something like 60%, because that will make it drop to 45% as a base case. 45%, 3 seconds. That's got to be easy. Maybe it's too easy, but we'll figure it out. That way, we don't need to do this, because we can calculate the accuracy through just subtracting all these things. Hide effect. Now this thing is, I think, fine to keep, because hide effect is probably going to be the same effect on everything, right? This one is basically when the player can't see the question, or the player can see only half of the question. So the accuracy drop should be pretty hefty, which is 45%, that's fine. And then now here's an interesting thing. There's an ordering issue, because we guess first and then we calculate the answer, because we then just find a random block. So I think this needs to move up, because we need to know, in order for this thing to be applied, it needs to know how many digits there are in the answer. This needs to move up a bit. So here's the base accuracy. Then we subtract the 45% if the player / AI, well, we mean AI basically here. So if the AI can't see the numbers, can't see the question, and we get let's keep this here for now. This should be the last thing because we don't want accuracy to drop below 0, because 0 basically means it will not guess. And somewhere here we need to find the block that we want to answer. Which is just this, right? Because this is the block, or this is the optional block. And then if block is present, I'm not sure what we want to do if it's not. Else don't do anything, right? Because if there are no blocks that are present, that means the AI cleared the whole thing, which means the game is, well, the level is over. The player has lost. So we only ever care about this case. This thing moves. Let's do it the other way. If the block is not present, is empty, then we return, because there is nothing to do. Block answer is what we want. Get the actual entity from the optional, then get the string, which is answer, and then num digits, which is answer length. Yep, because it's a string, so it gives us all the digits, that's fine. And then accuracy needs to drop by num digits multiplied by AI's how do we get the AI data? That's how. AI data get difficulty, accuracy drop per digit, and this will drop accuracy even further, and then we cap it at 0. We'll cap it from the other side at 0, which is fine. Okay, this is cool now. We can refactor this easily, because it's the same in both branches. So AI is not ready to guess, because it has already guessed, so it's going to run this. We already got the answer, so it's animate with this answer, or animate using a random, just put garbage to the input. Can we make this a bit more interesting? Because we know the number of digits, so it's, if the number of digits is 3, we want to go up to 999. Or we just make it between 1 and num digits multiplied by we can't, because num digits only gives us the number of digits in the answer. So if we wanted to go from 3 to 999, from 2 to 99, we need to add that many digits to something like a string and then convert string back to an integer. That would be one approach. The other is to just keep multiplying by 10, 100, and 1,000, and so on. Wrong answer. Wrong answer max or something like that. Number of digits is going to be at least 1, right? So it's between something like this, and then integer pass int. What's wrong with that? From string to string builder. Yeah, no. Okay, let's see how the easy AI performs. And then we'll do one with nightmare and then see the difference, if there is one. 22, 31, 44, 30, 22, 25, 23, 36, 25. Okay, so basically easy AI is indeed easy, which is good. We can beat it. And if you get, if you keep getting streaks, then it's going to hide the AI's blocks in terms of like the questions, like here, which means it affects the AI even further, which is what we want, particularly for nightmare, because nightmare is really fast. Let's try nightmare one. It is really good. I should say it's still good, even after all the things that we applied to it. It almost killed this entire column. That's brilliant. Yeah, so it's doing really well in idle, as in if there are no negative things applied to it. And what happens if we try and apply various things? It still guesses with really high accuracy value, even if it's hidden, as in it can't see the things. Let's try it one more time. And then we'll see if it actually has any effect on it. Because if it's not affecting it, then we need to apply some kind of, well, we need to do something about it. Like, you can't see the questions now. Okay, so it is kind of failing a little bit, which is good. Because the point is to make it reasonably good, but not overwhelmingly good, because the player needs to actually beat the AI. That's the whole point, right? You don't want AI that's super effective. Yeah, so I think it's playable. And when it's not hindered, it just goes to town on everything, which is cool. Also, one strategy is to go horizontal, because horizontal is going to give you more kind of streak points, which in turn makes a lot of bad things happen to the other player. And the AI will, well, it goes kind of randomly, but because of the order of items within the stream, it will always more or less go for just one kind of vertical block. Okay, that seems fine. And then obviously as the levels go higher, it's going to get more difficult, because the first level is only just additions. So if we change it to like level 3, 4, so this is where things get really interesting. Because in terms of the operations, it doesn't hinder the AI. But obviously, if you're adding small numbers together, or if you're multiplying big numbers together, that makes a difference to the human player. So maybe something needs to happen in terms of the operation that's being performed by the AI, or something along those lines. But for now, I think I'm quite happy with what the AI is able to do. It's going to keep the players occupied for some time. Right, so the power-ups now do affect the AI, which is good. Let's get rid of that. Right, is there anything else that can be easily fixed for now? So we got that, we got that. The AI is going to do this. Yeah, we need to figure out how to use these effects, or how to apply them in a kind of orderly manner, because currently the way they're applied is just very ad hoc. So all of this needs to go and get fixed at some point. Random 10, not top 10. Yeah, so the big numbers effect, which actually I don't know, how is it applied? Where is it applied? It's actually not applied even. So we need to figure out what applies this effect specifically. And then when it does, it changes the blocks question to something a bit harder. And it needs to change that for 10 blocks, it seems, 10 random ones. Right, but I think for today that's good enough. The AI is playable, which was the goal for this one, and we need to figure out what to do with the score. Seems like more to-do items. Score needs to affect something. Big numbers effect needs to be applied through gameplay. Right. What do we do here? So we went and we added a score, which does nothing for now, and we fixed the AI's hindrance level, so it actually takes a hit when some kind of negative effects are being applied, which is good. You can get this source code easily from here. I'll put the link in the description so you can play with it. Just Maven JavaFX run, so basically this should do it if you're not running through an IDE, and if you are applying through IDE, then you should be able to just get it in IntelliJ through Maven. That's the easiest approach. Feel free to add stuff to it if you want to. and we'll go from there. Thanks for watching. Bye-bye.